My name is Chugh, and I'm going to demonstrate one of the telemetry use cases for the mining industry. So, as one would have in the setup, uh, in each mining site, you have haul trucks which would load the mining material from the loaders and take them all the way down to the crushers. And these haul trucks, they have a lot of data provided by the IoT sensors on the trucks. So this data can provide information about the engine health, the speed, location, payload, the state of the trucks, etc. And these sensors, they provide all this data over the MQTT protocol. So the end goal that we're trying to demonstrate is how you can use this information and provide a platform that a telemetry platform that will capture all this information and provide it in a form which can be visualized or can be integrated to downstream further larger analytical systems, so that the overall operations of this site or across sites can be enhanced looking at that data. Yeah. So what we have in terms of the setup, so we have simulated the vehicle fleets, loader, crushers, trucks, sending sensor data via MQTT to the MQ broker using MTLS. And we've simulated a couple of sites. Now, once the data reaches the MQTT brokering layer on the Openshift cluster running in the DMZ environment, that data is further transferred to Kafka using MQTT to Kafka bridge written on Quarkus using Camel. An alternate option here is to use Kafka Connect as well, and then use the open source connectors from Camel. So once the data reaches Kafka, the other application that we've written is called a metrics aggregator, which is going to aggregate those metrics and push it down to Prometheus in a form where they can be really understood. So in order for us to capture these metrics into Prometheus, we have enabled user workload monitoring on OpenShift. And then further down, we use Grafana to visualize those metrics. And we've also used Cert Manager to manage all the MTLS certificates. So each truck is going to have its own certificate, own identity presented to the broker, and it will be configured with the permissions that it can only publish to that specific topic and not to any other topic, for example. And as part of like further extension, what can be done is we can hook Kafka onto external systems like a data warehouse where we can send a large number of this monitoring data, which can be further used by BI systems downstream. So we'll look at the first thing first, show the setup that we have for simulators and the brokering layer before we jump on to the further parts of the system. So what we have on here on the OpenShift side of things, so we have created two project namespaces, site alpha, site beta, which demonstrate 20 different trucks on each of the sites. Each of these trucks sending their sensor data every few seconds. And then what we have on the broker side, we have installed the AMQ broker operator on OpenShift, and we have configured this broker to run two standalone brokers. So they're running not in cluster environment, more in standalone for better scalability. And they've been configured with the SSL configuration, and also with some additional configuration which identifies that provides all the authorization for the trucks. So like I was talking about, like each truck can only publish to its own specific topic, and each truck has its own identity for an MTLS. So this is where the configuration reference goes in. So just quickly looking at some of that configuration reference. So if you look at this site roles BP secret, so here we see that we have defined security roles that truck 000 can only publish or consume messages from this specific topic. itself. And similarly, truck 001 can only operate on the topics meant for it. And then there's some additional configuration which is used to identify each truck's own individual identity and the roles and permission it has. So that's on the broker side. Once we, in all of this, again, we use the cert manager with its own issuer, which helps to automate issuing of certificates and injecting them into the secrets for consumption by the broker or the application, for that matter. The other part of this is setting up Kafka. So once we have configured this part with all the MTLS configuration, the next part is to configure a set up a Kafka bridge, which will publish all this data onto the Kafka cluster. So with that, again, we have installed the streams for Apache Kafka operator. And if you look at, we are running Kafka both as a controller and a broker with the dual role. And so we're running a 3-node Kafka cluster. And then we also have, in terms of the application, where we have our MQTT Kafka Camel bridge, which is going to do that transformation for us. So just quickly, I'm going to showcase what that bridge looks like. So it's a simple Java bridge where all it does is, other than ensuring that it's using the correct connection factory for SSL, is just simply picking the messages from AMQ broker from MQTT topic, and it's going to add in some metrics, and it's just going to go ahead and publish that message onto the Kafka topic. And in between, all it does is extracts the truck ID and the site ID and use that as a key on the Kafka topic. So a simple bridge which does all this transformation, publishes the messages onto Kafka. And once we have the message going on Kafka, the other application that we use here is called the aggregator, which is, if we go back to the diagram, the metrics aggregator, which is going to capture all these metrics and publish them onto Prometheus. So again, looking at some of the source code here. So this is a simple Go application, which is, as part of the link, you can have a look at the source code, but all it does is it captures all this different data points that it's getting, whether it's with regards to the signal, the truck state, the truck target, where it is going, the system temperature, system memory. All these informations is going to extract that and publish all that data onto Prometheus, which is local to Openshift. So with that being said, so once the data is published onto Prometheus, we can now look into the Grafana setup that we have. So we have Grafana up and running as well, Grafana operator installed on Openshift and configured with a couple of dashboards. So here we see in one of the dashboards, we can look at, all these different trucks with all their metrics being captured, their speed, their latitude, longitude, location, how much payload they're carrying, what's the ID of the truck itself, what's the state of the truck in terms of it's driving to the crusher or it's driving to the loader, for example. And we can, further drill down based on, if you only want to look at some of the specific truck informations. So it provides you with all the information, the fuel levels and things like that, depending on all the sensor data that you're capturing, engine speed, etc. So once we have all of this information available to us, so we can either use it, at the DMZ layer, or as time progresses over, we want to analyze over the larger chunk across multiple 15 or 20 different sites, depending on how many sites we have. All this data can be further pushed on to your data warehouse, and that can be further utilized for further enhanced analytics or AI as well. So with that being said, that's pretty much the demo that we have here. Thank you.